Well, hi, good morning. Thanks so much for joining me in my shop here. Today is November 9th, and what I'm up to today is I'm hoping to operate this radio pretty much in the condition it's in right now. I have just a few things to resolve first. One of them is, why is this capacitor hanging here? Another one is not really something that it needs to be resolved, but I have to figure out how to hook up the A speaker. And here's the button set, which I removed from the radio. Look at the amount of dust in there. This is, wow, that's bad. That's all the push buttons. These have to be plugged in for this radio to operate. And the radio requires a field coil type speaker. Here's the field coil. Speaker's missing. And I'm just going to hook up, this is the voice coil leads from the transformer, which you cannot quite see back there. All I got to do is hook that up to one of my shop speakers, a small shop speaker. But I think a good thing to do next is to go through the schematic, study it a little bit, study the service manual, kind of see what's in it, and then study the schematic and try to sort out this little capacitor and anything else that needs to be taken note of before I start trying to apply power to the radio. So let's check the schematic, or check the service manual here. Okay, here we are. Service manual for two versions of this radio. The A25 and the A38. This is the A38, the one that I have, which you would have seen. This great big cabinet, that's exactly it. That's exactly what it looks like. And I own a radio very similar to this. It's not an RCA. It's a KL76 or something like that. It looks almost identical to this. Speaker opening slightly different. And I see I did an A25 back in 2014, which did look exactly like this. I don't remember much from 2014, to be honest with you. So we'll just take a look here. Loudspeaker, 3 ohms, very low impedance, 3 ohms at 400 cycles. So what I can do, A38 and A25, so we better pay attention to that. A38, 3 ohms. I've got 2 8-ohm speakers here. I'll just parallel them and get 4 ohms out of it, and that'll work just fine. For now, if we look at the tubes, I already pulled the output tube out, and it was not a 6F6, it was a 6K6. Now, those could be directly swappable. This is a 5Y4 rectifier. Maybe we're going to take a look at that right away. I imagine all these tubes are correct. Let's just check out this 5Y4 and be sure. I'm just going to take a look on my own here. Okay, got the rectifier tube in my hand, and it is a filthy, filthy tube here. Here, have a look. Pull it out of the socket right there. Certainly looks like a 5Y4 or a 5Y3. So you cannot exchange those two tubes. My gosh, it's just, you can see no hint of the tube name. So I'm going to clean this up. I'm going to take a better look at it. It's pretty clear to me that this radio is in the house of a heavy smoker. I can just smell cigarette smoke coming off this. And I think that's mostly what I was cleaning off this tube. But unfortunately, the number is definitely washed off. I can just see the edge of the number box right here. though, it's probably a 5Y4. I mean, I really don't have any good reason to think it isn't. But maybe I'm going to put that through the tester right away too. Why don't we just get that over with? Okay, let's find out if this is a 5Y4 and if it's any good at the same time. So I have this set for 5Y4, but let's double check. So filament voltage 5. And the pin settings 0030P, 0030P, 0760, 0760. Okay, is that right? Sensitivity 25, plate is E. A note here F, which means there'll be a short on one pin. And then 2 plates to test, P1, P2. There we go. Well, it's heating up. That may actually be evidence right there. The heaters may not be the same pins. Let's take a quick look. I'm kind of going overboard on this, but why not? 5. So 5Y4 heaters are 7 and 8. 5Y3, that's what I'm worried it may actually be. Heaters are 8 and 2. It's got to be a 5Y4. Or it wouldn't heat up. Okay, checking for shorts. There's the note saying there's a short on the first, on the test number 1. Diodes and rectifiers, all we got to do is get above this rectifier mark, just where my finger is. Right on the line, second plate. Right on the line. That's good enough. Good enough. Okay, that's 1, 2 taken care of already. Wow. Okay, now the output tube in here is a 6K6, but it's listed on the in the information as a 6F6. So this is my tube substitution handbook. We'll take a look in here. 6F6. 6F6 can be replaced with various other 6F6s, 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 6. They're all 6F6s, replacing 6Fs, 6s. What about a K? 6K. E, F, G, H, I, J. J, K, 6K. Wow, a lot of 6J tubes. 6K. 6K6. Can be replaced with a 6K6. Well, there's just a whole bunch of other 6K6s here. GT, G, MG. Wow, this is saying no, you can't do that. But there it is. You better just take a closer look at the situation here. Take a look at the tube manual for 6K and a 6F. We'll compare them. A, B, C, D, 6F, 6F6. Big write-up on it. And then a 6K. So a lot of these tubes that are similar number like that, they can be swapped back and forth. There's a 6K with a large write-up on it. So just looking at the pinouts. So 2 and 7 are the heaters, plate on 3, cathode on 8, 2, 7, 3, and 8. Over here, 2, 7, 3, and 8. Okay, they look like the same pinouts. And we can find G1 on 5 and G2 on 4. 5 and 4. G15, G24. So what's the difference? So we look at the heater current. Heater current 0.4 amps. 0.4 amps. 6K6, 6F6. Heater current 0.7 amps. 6F. A lot more heat. A lot more current anyway. Is that right? Did I read that right? 0.4. Wow. Okay, so 6K in terms of heater current is preferable. What about the duty of these things? So probably under cathode bias, a 250, 285 plate. 6K plate. That's maximum typical operation. Up to 315 on the plate. 315 maximum on the plate, and then you get the maximum plate 375. So a little higher headroom on the plate voltage on the F. So the K is a little more. Looking for a slightly lower B plus, maybe. Typical operation. Maximum signal power output around 10 watts out of this guy, and the 6K power we can put out about the same, 10 watts. Okay, and we look at the grid bias. Typical operation. This is a single tube here. Grid number 1, minus 16, minus 20 volts. Minus 16 to minus 20 volts. Depends on the plate voltage. So how's that compare? 6K. Oh, I just lost my page mark. 6K grid number 1 voltage. Well, it starts with minus 7 at a very low plate voltage, but at a similar to that other page, minus 18, minus 21, same kind of plate voltage. So, and the last thing we should look at is probably a plate resistance, and maybe transconductance. So the plate resistance on the 6K6 is 100,000 ohms, and the transconductance is around 2,000. So 100,000 and 2,000. 6F. Plate resistance is lower, 78,000. Transconductance at 2,500, just a little higher. So they sound pretty similar to me. I was surprised that they can't be plugged one for the other. Sometimes in these books, the substitution book, they'll say you can go from this tube to that tube, but you can't go from that tube to this tube. That's quite common, but I couldn't find it in either. A cross-reference in either one. Well, we'll keep that in mind. Maybe I'll do a little extra research later. But and just how filthy dirty is this? Oh, just about fell right out. Well, it's not filthy dirty at all. How come he's so clean? That rectifier was a filthy mess. In fact, now that I look at it, the other tubes all look, well, nothing looked as messy and dirty as the 5Y4 in there. Okay, just hunting for any mysteries that we could find. Let's go back to the service manual. Okay, what can we pick up here that might be worth knowing? Tuning eye, 7.5 volt lights, 0.2 amps. Could be little lights. We already looked at the loudspeaker. General description. These receivers employ a 7-tube, 6-band superheterodyne circuit, the arrangement of which is shown in the schematic circuit diagram. Features of design include loop antenna as the first tuned circuit. That's important to note. As the first tuned circuit. You notice they're not saying for the AM or the broadcast band only. They're just leaving it up in the air. So normally these loop antennas are only utilized on the broadcast band. High gain RF stage, stabilized oscillator circuit resulting in less frequency drift. They're probably referring to some capacitors that were used in the oscillator circuits. Magnetite core IF transformers. Hey, voice. Magnetite core IF transformers, magnetite core oscillator coils on all bands. I'm not sure what the thrill is over magnetite, but maybe this was a new material at that time. Automatic volume control, AC outlet on chassis back apron. Tuning indicator tube for fine, accurate tuning on all bands. Variable tone control circuit. Push button tuning of 5 standard broadcast bands by means of preset oscillator coils. Dust proof electrodynamic loudspeaker. Well, we don't have that. We have a replacement speaker. A permanent magnet type speaker. Temperature stabilized capacitors in the oscillator circuits. Wait, isn't they saying the same thing twice here? Hey. Hyperbole. And a large edge lighted dial individually calibrated for each band. So edge lighted is actually a very, very important thing to realize about how the glass works in the front of a radio like this. Circuit arrangement. The circuit consists of an RF amplifier stage incorporating the loop antenna as the first tuned circuit. Once again, they're not saying broadcast only. First detector or oscillator stage. The word detector was used for what we commonly call the mixer tube over here. Back in the day, IF amplifier stage, second detector, AVC, first audio stage, and a single pentode output operating in Class A. Tuning indicator, and a well-regulated power supply. I think their marketing department got a hold of this document and threw in a few extra words here and there. The loop antenna used as the first tune stage is in the circuit on all bands. Oh, the loop antenna used as the first tune stage is in the circuit on all bands. Temperature compensated capacitors are used in the oscillator circuits to reduce oscillator drift. I'm sorry, that's 3 times now you've mentioned this. Spread band tuning is accomplished electrically by shunting the oscillator section of the variable capacitor with relatively large temperature stabilized fixed capacitors for tuning the oscillator coils on the 16 to 13 meter band, 19, 25, 31 meter bands. Let's read that again. Spread band tuning is accomplished electrically by shunting the oscillator section of the variable capacitor with relatively large temperature stabilized fixed capacitors for tuning the oscillator coils. Okay, relatively large. Antenna and detector coils are designed to be sufficiently broad tuned to require no variable tuning over the narrow frequency range of the spread bands. Okay, what? Antenna and detector coils are designed to be sufficiently broad tuned to require no variable tuning over the narrow frequency range of the spread band. So when you use a spread band radio, even though the dial may be going a foot in either direction, you're actually tuning a very small part of the overall spectrum. So it's easy to have fixed tuned circuits that in fact cover the range that the radio is tuning through, because the range is actually so small. So that's why they're saying. That's why that's interesting. So that's a big advantage of of a spread band radio. The RF circuits can be fixed in their tuning, band for band. The intermediate frequency amplifier consists of a type S6 SK7 tube in a single stage transformer coupled circuit. The windings of all IF transformers are resonated by fixed capacitors and are adjusted by molded magnetite cores to tune it. Okay. Here's the layout of all the important components. That is the tube position layout, which we should probably check just to be sure, considering how easy this tube came out. Maybe they all look kind of clean, a little bit clean. Maybe they've been shuffled around. You have 6 SKs here, the front end RF tube and the IF tube. That means we really can't operate this radio properly on any band without this guy being plugged in. It's never been in my head before. I always thought, the shortwave antennas on the back here. Well, we'll look at the schematic when we finally get there. Alignment procedure here, okay, fairly involved because there's so many bands on the radio to do it. And we won't study this now until the time comes. Here's the schematic. The schematic. Okay, question about the antenna. So here's the antenna terminals on the back of the radio where I would hook up the shortwave antenna. And sure enough, it's coming right through. Right through. Is it? A, B, C. I'm quiet here. So I think these are the three, represent the 3 prongs on the plug from the antenna, which I left out in the cabinet. I didn't bring it in the shop here. I'm going to have to get it. So it looks like the only way you're going to get all the way to the grid here on this tube, go through the switch. It's not obvious because these switches make it not obvious. Well, maybe we just trace the wire in the radio, the antenna wire. We can see where it's going. But it would look like one of the 3 wires coming from the antenna is nothing more than connected to this out the back. Capacity antenna lead. This is probably the piece of wire I cut off. A lot of these radios have what's called a capacity antenna, and sometimes it's just wires zigzagging kind of over the top of the radio, mounted to the underside of the top of the cabinet, if you can kind of follow it. I really didn't look for that in the cabinet, but I didn't see it. But all that wire came out. That maybe, I don't know. Don't know the influence of the capacity antenna anyway. I don't really know what it's there for. It's not really been detailed anywhere. Okay, let's shoot through this schematic. So we have a front end RF tube. We have lots of coils. And we have the did I call that a tube? This is the tube here. Through here, through this. So this is these switches are selecting coils and capacitors as you change bands. This tube's mixing the local oscillator in. The local oscillator is coming from down here. A lot of these fairly small capacitors. These are these black ones, some of which were cracked. And it said that there were temperature compensated or compensating capacitors in here? Are they marked? It just may be these little half moon circles here are representing. I don't know what they are. Well, it's a bunch of them. It doesn't come right out and say this one is temperature compensating, though, does it? Okay, so now we have the signal mixed in here. One of the components coming out is if you tune the radio to a station, that's kind of a weird way of saying it, will be 455 kilohertz. That's going to race through here, get amplified there, race through this, and meet up with the combo detector first audio amp 2. So can we see how the detectors are done? So two little plates here, it's hard to see. One is connected this way and the other is connected, the other is shorted to the cathode. So, so we're only dealing with one plate. Okay, and we come down through here. We must encounter the volume control. Come down. This is that first push button switch. And if you push it, you're selecting the phono socket and cutting off the radio signal. Otherwise, the radio signal is just feeding through. It's coming out of the radio, feeding through and heading back up. Top of the volume control, bottom is grounded, solid. Okay. So just following this back, we get a big 2.2 megohm resistor here. So this would be certainly the automatic volume control, or ABC line. It's going up, driving the grid, yeah. Coming down, driving a grid on the magic eye tube here. Very good. There's nothing unusual here. These are fairly standard built radios, I guess you could say. The tone control is designed to dump treble. So as you adjust the tone control, you're just rolling off the treble side of things. Okay, so the signal coming out of volume control is fed. Oops, I missed something there. Fed to the plate. No, it's not. What am I seeing here? This isn't quite right. Wait a minute. This is another resistor here. This is the slider. Okay, got myself turned around. Thought this big thing must be the slider. No, this is a fixed tap. This is the slider here that you're turning when you adjust the volume, feeding varying amounts of the signal onto the grid. Right. Then the plate signal. That's got to be plate resistor there, I think. Plate load. Here too. Blocking capacitor, grid, and the output tube. That's going to be 390 ohms. That's a cathode resistor there. So that's how this tube is biased. And then the plate running through the output transformer. Shows the hum coil here. I don't know if that exists still because of the change in the speaker, but I don't think it's important anyway, because the field coil, which I guess they've shown down here, yeah, they've shown it down here in the power supply. The power supply, we need to look through that. There's some diagrams of coils, and okay, we should look through the power supply. The power supply is isolated on the primary side, nothing is attached to ground. This is showing a ground on the frame of the transformer, and all the iron, probably all the iron is grounded here. So this is like an isolation transformer. So we get on this side, we have the rectifier, and working off both sides here. Why is this number different? 735 ohms. Oh, frequency. 25 cycles. That's the resistance, I guess, you would measure. I'm not sure how to read this. Maybe they're saying if you've got a radio with a 25 cycle transformer, then you'll find 1,000 ohms in it. If you've got the 60 cycle version, which is what's here, the back plate says 60 on it, it's 735. Okay. They give us the resistance of the field coil. I'd have to guess the one that's come with the radio is the original, from the original speaker. We got the two small filter capacitors because most of the filtering is actually being done by this coil. So in fact, this radio will work with very little hum, even if these capacitors are not doing their job well. That's the power supply. We have just one output. For everything. Sometimes they'll take the output for the, well, they wouldn't do it in this case, but in a different kind of filtering here, where the first filter is fairly effective. Sometimes that's good enough to supply the output tube, and a better filtered power is taken from the other side of this is usually a resistor and a couple of large capacitors and a different style of filtering, but not here. It's all coming off here. A couple of hints here. We should read these notes. Oscillograph connections, if you want to make them when you're doing so this is actually, this point is actually top of the volume control. It's just through here. It's a long piece of wire. So top of the volume control. A good place to measure the AVC voltage with a meter, with a voltmeter also. The socket here, this socket is very inconveniently located on the push button assembly, tucked up way in the radio. I mean, you really have to get down your hands and knees with a flashlight to plug in your record player, or a Bluetooth receiver. You could try that later. And the push buttons has both trimming capacitors and trimming inductors. Inductors for the oscillator, capacitors for the antenna. But these you only can store broadcast frequencies in here, AM radio frequencies. Any other notes here that I missed? Don't think so. Okay, onward. So the next thing we've got here is the wiring diagram, pictorial version. This is really handy stuff. This is really, really handy stuff. And with this, we can figure out what that capacitor, the freak capacitor, is. We'll come back to it in a moment. And they're just talking about how to do the push button adjustments. Oh, here's a voltage table. This is very helpful too for double checking the voltages on the tubes. Typical plate voltages are in the 200 volt range. The output is at 205. That's way below the 315 limit. Way below. Screen grid, interestingly enough, has a higher voltage than the plate. Cathode 13 volts, that represents the bias voltage. So at 200, I don't remember what it was, but it wasn't 20. It was below 20, so this must be correct. There again, that's within a range of the tube that's in there, the 6K6. Parts and the stringing diagram, which luckily I do not need to pay attention to, at least not at this point. Okay, so we're going to use this diagram here, and we're going to figure out what capacitor it is that is sticking out. Let's look at the radio here. The sticking out capacitor. It's right down around the output tube. That's the output tube socket. If it were to go to where it appears to want to go, it would be right here. This is a tube pin, and it's coming from another tube pin. This should be easy, assuming those are real active tube pins as opposed to spare ones. Now, let me count. This is so dark. It looks nice and bright on the video, but it seems very dark. Why so dark? Okay, so looking for the key, the tube key. I'm trying to feel it. That's not going to work. Let's look with this. This capacitor's right in the way here. I'm looking for the little bump on the. Looks like it's down at the bottom there. Okay, so I'm gonna pull that tube out. Maybe we can see it. There, now we know. Now there's no question where the key is. So we're counting pins. So we would start with this one, number 1. 1, 2, 3. So 3 is one of the connections it wants to go to. 4, 5, 6, 7. Between 7 and 3. Between 7 and 3. Okay, let's look and see what we can see on the schematic. Okay, where are we here? So we are looking for, I'm all spun around, looking for the opposite, looking down in this area. There it is, 6F6. There's the key. They show you the angle even. Now, there, this is probably it here. C34. That's going from 1, 2, 3 around to 8. Is that right? Was that where it was going? Just looking again. That's right. That's exactly what it is. C34. Between the plate and the cathode. C34. Okay, plate and cathode. So come up here. And look, plate and cathode. Plate. There it is, C34. 0.005 over to the cathode. Not exactly sure what it's doing there. Now, we'll go back to the camera here. 224K. I have a hard time, those don't snap into my head. 224K, it's supposed to be a 0.005. What's the 2's doing there? 0.005. 0.005 would be 502K. And that one, well, it's way off. Size-wise, it's way off. 50 times 50x3. I don't know what that is. That size just look. I think it's way off. Let me look into this a little bit further. Time for a little bit of a coffee break for me, anyway. So I think it's a 0.0002. And it's supposed to be 005. That's quite a difference. Let's just see what this says. And it looks like somebody's junk box capacitor. That's what it looks like to me. There we are. So 200 nanofarads would be 0.0. Well, so it is what it says it is. 0.0002. So why is it disconnected? If you put too small, I think if you put too small of a capacitor there, you just get too small of an effect, whatever the effect is supposed to be. Well, maybe that's it, but then you removed it, you have even less capacitance. You have no capacitance, or extremely small amount there. So I think I may want to replace that before firing up this radio. Yeah, I didn't have that coffee, so I'm going to have that coffee now and ponder my next move with this radio. Okay, nice shiny new capacitor installed there, as required according to the schematic. Now let's just take a look at this antenna situation here. So we have the two terminals up here, A and G. A is hooked up to a wire. This is the wire. This is the wire right here. It pops into a hole there. And from there, looks like it might be a little tough to see what's going on. It's in behind that coil. Well, the other thing that's right there is that's where you plug in the antenna in that socket right there. So I'm going to have to go with what it says. That, or do I? Do I really? Okay, so I can see the wire coming in, and it connects to one of the 3 pins on the antenna. I didn't know that. Oh my gosh. I've made mistakes with these radios in the past. Because often I just don't bother with with having that big antenna hooked up. I'm gonna have to get it out of the cabinet. Now I've got the speakers hooked up. Here's the connection of the 2 speakers in parallel to the voice coil output from here. And then this guy's got like here, it's got to reach. It's got to reach this guy. Set this down now. Put the rectifier tube back in. No, yeah, output tube. Okay, we'll just go with the one that came with it. It really doesn't feel very secure in there. Maybe we'll just take a quick look to make sure these are correct. 6SK, that would be correct. This should be a 6SK here. 6SK7. This is the 6SA7, yep. And the last guy over here, 6SQ. That's right. That is correct. Let's turn it around so we're facing it. So this is nicely flexible. Lucky break there. Lucky too, whoever did the work on the speaker maintained this plug and socket arrangement. Makes that pretty easy. Now, a little bit challenging to get these buttons set up. They literally have to sit in the same location where they sit in the radio for all the wires to reach, especially these guys on the side. So I got to set that up, and then I think we'll be able to turn them on. Turn them on and stand back. Okay, just part of getting this ready to try to play was to go and get the antenna out of the radio, which is normally a really easy thing to do. But look, I had to take the whole bracket off the bottom here. This one, we're using a cotter pin way down there where I couldn't really see what was going on. A cotter pin holding this together. See, it's spring loaded there. So this antenna is held tight to the bracket. And you see there's a little stopper right where my finger is there. So when this swings around, it can only go that far. So it can only go around that far. What a clumsy arrangement. But anyway, I have the whole thing here. Now the wires are actually going to be good enough. I can just make sure they're not shorting. Here on my bench I should be able to plug this right in the radio. Not saying it's going to work all that well in here, but we just need it in. Okay, so again, the reason I'm anxious to get this radio and any radio working as soon as possible is because it answers a lot of questions about the condition of things in the radio. Can answer a lot of questions. Are the tubes good? You know, stuff like that. Set that over here somewhere. There. Good enough. Nothing shorted. Got the push buttons in here. Got the wires on the side. Got the main cable plugged in. Got the speakers plugged in. We are ready to go here. So, the one thing we're not ready for, there's no power cord on here. Now I had noticed that I could plug right into the back and sneak power in through the outlet, in through the outdoor. On a temporary basis, that might be a suitable way to go. On the other hand, I'm going to be doing this quite a bit. I may as well solder on a real power wire here now. That makes sense. Okay, so we have a new power cord put in. Good. Now I think we're ready. We're not just gonna, sort of plug it in, turn it on full blast. We're gonna do this in a couple of steps. Okay. Everything's still hooked up. Yes. Okay, so the only antenna to start with is going to be this antenna, and the band we're going to want to be on. I gotta put this back on here, so we know where we are. Okay. Start with the broadcast band. Volume down. This might be volume. Switch is on. So first thing we're going to do here, whoops, can't be turning this too much. I'm going to get this old cord out of here. I should have just put this back on. Oh no. No. Okay. That aside. here so we don't have a lot of unnecessary stuff on the bench in case we have to think fast, act fast. What would that be for? So what I'm hoping to achieve here is just to get some noise to come out of the speaker, and if I touch the antenna terminals the noise changes, and that's good enough, but we might get a lot more of this than that. Let's find out. First I'll make sure that this button is not depressed. Pushing another button. What makes these buttons operate? Just pushing them in takes over? Must be the case. You just push one of these in and it takes over from the knob here. Okay. Make sure this is set right. Here. Nothing is gonna catch fire. Well, who knows? We don't know about that. So first thing I'm going to do is I'm going to reach around. Right, can't do this. And pull out the rectifier tube. Okay, rectifier tube is out. There's various ways to do a slow startup on a radio like this. Another option is to not actually plug it in, but to power it temporarily from shop supplies. And we might end up getting there yet, but for now I'm going to pull out the rectifier tube. That'll make sure there's no high voltage cast through the radio, so the bulk of the radio will be dead, and we'll find out if that draws too much power because something's wrong. That's what we're trying to find out. Is there something seriously wrong here? So I have a dim bulb system over here. Get these two light bulbs. When I'm going to feed power to the radio, I can feed the power through those light bulbs on the way. That will restrict the amount of power coming to the radio. I'm going to highly restrict it to start with. So my expectation is I will turn this on. The tube should heat. The lights should come on if they're any good. And that's about it. Not much more should happen. This light is the one that's going to be conveying the power. It should probably come on a little bit, but may not even come on at all. We will see. It may come on bright and then dull down a little bit. That's the plan. Now, you probably see this guy in the video. I'm not really utilizing him for this. I'm going to utilize the dim bulb. Let's plug it in now. Regardless of this guy sitting here with a big transformer in it, there's another transformer behind this that's providing the complete isolation. So this is an isolated supply, even though it's got a third prong. It's baloney. There's the third prong sticking out into space. There's no third prong grounding related to this. And then this thing's own transformer sets up another isolation, if you like. Okay, have I talked myself into doing it? Yeah, I think so. Okay, so I've got a couple switches here on the switch panel. This panel here. Push this switch down, power goes through the lights. Push the switch up, and it doesn't go through the lights at all. It goes straight to the unit, so it gets full power. If there's a problem, serious problem, the light will come on full bright and stay that way. And then we'll know, oh, that's a really bad sign, so we don't want that to happen. Okay, just taking one last look. So the switch is on. It's probably good to step back a little bit. You can see where the smoke comes out very clearly. There we go. Okay, so that's exactly what I wanted to see. So what's happened, look at the lights have come on here. Hey, two good light bulbs, though this one's a little dull. May not be the right kind of light. And that's it. So that's the initial test. What this proves is the power transformer is good. There's nothing seriously wrong with that little bit of the start of the radio and the power supply. So I'm going to kill the power. And we're going to take the 5Y4 tube, which I cleverly placed over here, stick it back in. This time the radio comes on. Once the rectifier tube heats up, it will begin to produce high voltage, or rectify high voltage if you like. That will go through the radio. Each tube will get its share of the high voltage. That will cause the tubes to conduct. So the effect on this light is, it comes on bright at first because the tube filaments are cold. A lot of current goes into them. The tubes warm up, the current goes down. As the tubes warm up, the rectifier is warming up. It starts to produce high voltage. That causes all the other tubes to start drawing power. The whole set starts coming to life, sound coming out of the speaker, and who knows what else. And the light should come back up a little ways. That's the plan. If I hit the switch and the light comes on and just stays on bright, then, well, we'll have to figure that out. With only one bulb in there, it may just do that. Okay, we're ready. Let's hit the switch. Here it goes. Prepare to run. No. So it came on. It's going down in brightness. Okay. Now we're watching for it to go up. Okay. Looks like it's starting to go up a little bit. Hard to tell. Very hard on the camera. Okay, turn it up a little bit. Going to hear something. This may not be volume. This may be volume. Okay, there's some staticky sounds. This light's gotten really dull. Can't even hardly see it in the video. Hear that? Okay, so there's something happening. Now, I'm going to give the band control a bit of a shake here and see if we hear more clicking and crashing and other sounds. Which one is the volume? We cannot tell. Okay, so there's no crashing sounds, clicking sounds from doing this. So, yeah, it doesn't really work. That's where we're at. Who's not warming up here? So the audio part of the radio is over here. These are the audio tubes. This is the output tube. This is the preamp and detector tube. Listening for little scratchy sounds. Oh, what's that? That's coming out of my speakers. So I may just be wiggling this thing so much it's making and breaking contact. It's warm. That's warm. That's warm. They're all warm, so they're all heating up. Now we're running the radio on low voltage there. Can you see in here? This meter tells you we're running it on 80 volts. That's a little too low. That could be why it's not working at all. So I'm going to raise up the supply voltage by screwing in another light over here. Okay, so I'm still maintaining the lights. Oh, there we go. How about that? We're around 90 volts now. Tone. Volume. Okay, well that's pretty reassuring there. 90 volts. 100 would be a little better. Let's continue with our experimenting here. I will now turn the band switch and listen for those clicking noises. that's pretty neat. So that's band 2. That's old police band. The volume up full blast, which is not a particularly good sign. No loud humming coming from the radio. Let's tune it. I'm on band A, which is the AM band. Well, this doesn't seem to make any difference. Zero change in the output sound. Okay. And what if I contact the antenna over here? So you can hear a variation there. That's pretty interesting. That's just what I'm looking for at this point. Okay, let's try the next band up because it was sounding. Can't tell if this is a tone. She's alive. So these are probably noise signals that we're hearing. It's a very low band. You would not expect to hear. So that could be the radio feeding back within itself, or it's just a signal out here in my shop from, who knows, could even be my soldering iron. Could be doing that. Now, that's a very typical sound I hear regularly in my shop. Definitely receiving. That means a local oscillator is working. It's the only way it does any of this is the local oscillator is there. Let's try another band. But if we go up, we need an antenna. So I'm just going to stop and I'm going to go set up the external antenna here. And we're still running with only 90 volts. So I'm going to turn it up just a little higher, up around 100. Okay, this says 150, but we're dropping a fair bit on these lights. The actual voltage at the radio is 100. You can hear the volume come up a little bit as I did that, but not much else changed. So this is connection to an outdoor antenna. I'm going to stick that on the antenna terminal back here. Okay, so we shouldn't be picking anything up. Okay, let's go back down to the broadcast band with the antenna connected. I'm not sure if this is. Doesn't seem to want to do anything. Nobody home on that band, but oddly enough, so we should not be picking up broadcast stations here. But it's good it's picking up anything. Okay, next band up is the what does that say? Oh, okay, I was wrong. Jim was wrong. I was kind of wondering what makes these push buttons come to life, and it's a setting on here. Okay, go back in. Okay, so this all makes sense now. That's push button, which means this is doing the tuning. Then no matter what I'm doing with this, I'm not changing any of that. Could try pushing one of those buttons. Let's try CFRB is 610. There's a wild chance of picking that up. Let's turn this down. Okay, we won't worry about these buttons, but it seems to me they're working. Okay, so now we go broadcast band, band A. Very good, Jim. You're figuring out a radio. So now we should pick up AM stuff, and we did. We picked up something down here. Lots of distortion to it. Next band up, this is band B. So this is now the first shortwave band, but very low. Shouldn't be anything here but noises and stuff. Right. Okay. Go up another band. There we are. 31 meter band. So this is 9 megahertz, I believe. 9. Doesn't it go down to 6? We could pick stuff up on this time of day. If it's, see. Nope. Next band. 25 meter band. I think that's 11 megacycles. Not a lot being heard here. That's the antenna off. Antenna back on. We'll hook up the antenna ground here. Oh, that made a difference. Distortion. So that's the 2 Cuba stations, I'm pretty sure. They're both Cuba and they broadcast roughly 3 months apart. Cuba's easy to pick up here. Going quiet at the bottom. Let's go down the band. 31 meter band, 9 megahertz. Probably nothing there. Pretty quiet. Probably nothing there because the radio's not performing well and it's just not the right time of day. 25. Okay, the 19 meter band. I think that's 25. Is it? Did I say 25? 19 meter band, 15 megahertz. And the last one is a range, 16 to 13 meter band. What can you do? This is not so band spread, this one. Nothing. On-off switch. Oh. Okay, so what that tells me is the tubes all work. They don't necessarily work well, but they work enough that we're able to pick up station or two. Broadcast band working a little bit. One of the shortwave bands working a little bit. All of them sound like they're capable of working. So I think we're in a really good position now. If you're going to work on a radio like this, and you're going to work on it before getting it to work, like for instance, if I couldn't make this happen, there's some problem in there that was stopping it from working at all. But I go ahead and start making component changes and whatnot. I can introduce more mistakes. Yes, I can make mistakes. And now I've got some unknown problem plus my own mistakes in there. Yikes. This way, at least, as I go through and start changing components, I can test the radio repeatedly and make sure it hasn't gone downhill, that it's going uphill as I'm doing the work. That's why I'm so anxious to turn these things on. And I have a way of doing it, a couple ways of doing it, and that's relatively low risk, using the dim bulbs and the like. Let's shut the power off too. So that's great. That's really pretty good. It's good for today, that's for sure. Tomorrow we'll start looking more seriously at the radio's performance. We'll start changing some capacitors. Start trying to bring it up in performance-wise, and get rid of the tired old parts that are in there. So ultimately, this guy should perform really, really well. So thanks a lot for watching, and see you on the next video.